In this video, I'm going to talk about how to look at how two variables relate to one another, or to ask whether they're associated with one another. We're going to start with religious attendance and gender, namely to ask, does religious attendance tend to differ between men and women? Another way to ask it, are men more or less likely to go to church than women or other religious services? We're going to use something called a cross-tabulation. People call it a crosstab for short. We have this general social survey data. We really aren't interested in just this several thousand people that are in this data set. We're interested in the entire United States. So we need to infer or extrapolate from the sample to the population. We can do this because of the way the sample is taken. It's a probability sample. I'm not going to get into that too much here, other than to say that one thing we do need to use is a chi-square test, and we'll talk about that when we get to it. First thing to do is to create a pivot table. In order to do that, I have to create a data table first. Control T. I'm going to call this GSS, and then summarize with pivot table. Now, with a crosstab gives you the distribution of one variable by another variable. There's that key word by. In this case, we're looking at attendance by gender, and many other crosstabs you'll create for this assignment, it's always going to be some variable by gender in this case. Now, the convention for crosstab is that, first of all, variable before the by is the variable you're trying to explain. In other words, trying to explain church attendance, or looking at the distribution of church attendance by, and then there's the by or grouping variable, gender. So we can call this sort of the main variable by the grouping variable. Another way to think about this is the first variable is the dependent variable, is the variable you're trying to explain. The grouping variable is called the independent variable. Okay. And this is the convention that we use with a crosstab, is to always put the dependent variable in the rows. Dependent variable being attend, drop that in the rows, and then the independent variable, or gender, sex, is in the column. And then in the values box, we'll take that first dependent variable again and drop it in the values box. Right now we have the beginnings of a table, but it's all sort of messed up because, first of all, these categories are not in any sort of logical order. You have 2 or 3 times a month, every week, less than once a year. We want them to go from the least attending to the most so that it looks logical and makes sense, and we can compare these figures. The other thing is that these numbers by themselves are not going to tell us anything. I just made a mistake by clicking on one of these, and it gives me the people in that category. Before changing this around, I want to first change the sort order here to make it logical. And before doing that, I note that there's some people who didn't answer the question, 10 women and 7 men, for a total of 17 people. We're going to get rid of those by going to the drop-down menu and unselecting that first blank spot. You should always do this. Get rid of anybody who didn't answer the question, or people for whom the question did not apply. For example, like the question we talked about in a previous assignment, did you cheat on your spouse? Obviously it only applies to people who have been married. So if the person was never married, they should be excluded from the crosstab. Now it's time to sort these into a logical order. The most frequent is actually more than once per week. So I want to take that and put it at the bottom. It's easy to do that. I can Control X and then go to the bottom, Control V, and note that these numbers follow. So I can just, in other words, I'm copying and pasting, Control X, Control V. The next highest category is every week, so I Control X, Control V that as well. The lowest category is never, so I can Control X and Control V that to the top. It's followed by less than once a year. Control X, Control V, like that. And continuing to put these in order. Once a year comes before that. I can do that. This is fairly simple when you get the hang of it. And now they're in order from never to more than once per week. Now, these numbers don't tell us anything for our main question. Remember, our main question here is what? Do men and women differ in terms of how likely they are or how frequently they go to religious services? These numbers don't tell us anything because there's a different number of men and women in the survey. Like most surveys, women, for whatever reason, more cooperative, something, they're more likely to answer this survey, and there's more of them in the survey. 2,236 versus 1814. So I want to get column percentages here. But I still need these counts to use for the chi-square. So what I want to do is I'm going to highlight this whole pivot table, Control C, and then Control V below. So I basically have two copies of it. And then I'm going to change one into column percentages and come back up here, go to the pivot table tools, and I want to show values as percent of column total. If you use some of these others, you're going to get very misleading results. The convention with the crosstab is to get column percentages so long as you have dependent variable in the rows and the independent variable in the columns. Or another way to say that is the variable before the by goes in the rows, the variable after the by goes in the columns. And now there's a lot of place after the decimal point, so I'm going to get rid of some of those. Now it does look like, from looking at this table, that women are more likely to go to services. You have 21% of women went every week versus only 15% of men. 9% of women went more than once a week versus only 6% of men. And this is consistent with what we find at the bottom here, where people who never go, about 1 in 4 men never go versus 1 in 5 women who never go. So it does look like there's a difference. It looks like women are more likely to go to services. The problem is that, as demonstrated in previous assignment, we only have a sample here, and it's possible that these differences we're observing between men and women arose just purely due to chance. For the same reason that if you flip a coin a bunch of times, you aren't necessarily going to get 50% heads and 50% tails. You might get 60% heads. If I flipped a coin 10 times, sometimes I get 5 and 5, but sometimes I get 6 and 4, sometimes I might even get 7 and 3. That doesn't mean that the actual probability that the coin is going to turn tails is not 50%. A lot of what this has to do is with its just randomness affects the results. It affects the results in the coin toss and affects the results of the sample. And we really want to know, is this difference that we're observing here, is it big enough that we can be confident it really exists in the population, and it's not just, okay, we happen to get a more religious group of women and a less religious group of men, because that's possible. The way we find that out is with a statistical test, in this case a chi-square test. And the chi-square test, to be done within Excel with no add-ons, is a little bit more complicated, so I've created a macro add-on which you can add into Excel, and the instructions tell you how to do that. You can see if it's there after you've done this by going to File, Options, clicking on Add-ins, and you should see chi-square listed. If not, you want to go back and follow the instructions to get that in there. The chi-square add-in allows you to use the chi-square function, which starts out with an equals sign like all functions, and then type in chi-square, and then parentheses, and then what I do is I highlight all the numbers inside the table, not the totals. If you highlight the totals, you'll get a wrong answer. It's only the counts inside the table. Close parentheses and enter. And it gives me a number like this, which is in scientific notation that E stands for times 10 to the power of, and in this case it's negative 11. So it's 1.3 times 10 to the power of negative 11, which is, needless to say, an extremely tiny number. Okay, if we were going to, you can notice this is in scientific notation. If we were to change this format into a number, it rounds to 0, which is a little misleading because it's really not 0, but if I increase the decimal points, this is what this number would look like if it was not in scientific notation. You can see why Excel has by default just put it into scientific notation so tiny. Now, that's a result that means nothing unless we interpret it. What does that mean? This is a chi-square test. Note it's chi-square, not chi-square. Hard C. And the chi-squared test gives us a p-value. P is short for probability. This is where it gets a little bit complicated. What the p-value tells you is it's the probability that if there was no relationship between gender and attendance in the population, this is the probability of getting a difference as large as the one that we got here. So if that probability is low, then it means that we can conclude that the relationship between gender and attendance is statistically significant. Statistically significant means that the relationship is large enough, there's a big enough difference, say, between men and women here, that it's unlikely we would have observed this kind of result if there was absolutely no difference in the population. And it gets a little convoluted, but essentially statistically significant means that we conclude there is an association between the two variables, in this case gender and religious service attendance. Now, how did I conclude that it was significant? Well, there's just a simple rule. If the p-value is less than 0.05, we say it's significant. If it's above 0.05, we say it fails to reach statistical significance. So, and if it's statistically significant, we say there's an association between the variables. If it's not statistically significant, then we say there's no relationship or no statistically significant relationship. In general, statistical significance basically is saying that the difference that we observe is large enough that we're going to conclude that it really exists, basically. Okay? And you can think about it in the same way as, for example, a coin toss. If you toss a coin 10 times and you get 6 out of 10 tails, can you conclude that it's actually an unfair coin, some sort of biased coin that's actually more likely to be tails than heads? Well, no, because it's actually quite easy to get that kind of result. What that means is, and if you had worked it out technically, what would happen is that result's not statistically significant. Okay, if we, on the other hand, flipped 1,000 coins, or one coin 1,000 times, and got 600 heads, or 600 tails rather, and 400 heads, now that starts to look suspicious, like a coin that might have been modified or designed in some way that was more likely to get tails. Now you're talking about more of a statistically significant result, or one that was likely to be statistically significant. Statistical significance, though, is not something we just guess at. It's something we run a test for. And basically, the bigger the difference and the bigger the sample, the more likely you are to find statistical significance. we have a pretty big sample here. We have 4,050 people. So smaller differences will sometimes come out statistically significant than they would if, say, we only had 400 people. Now I want to show you one more crosstab with the next variable that you're going to look at, and we're going to do the can trust variable. This is one where people were asked whether they thought that you can trust people, and they answered how trusting are they, and we're going to do that again by gender. So I'm going to go back to my table tools here, and actually there's a number of ways we can do this. We can create the pivot table again and go through that process, or what I can do actually is I can highlight this table that I've already created. I'm going to copy it and then create a new sheet and paste it into this new sheet. Make sure you paste everything there. And then I'm going to substitute can trust for attendance. So I take out attendance and I drop in can trust like that. Okay. And we have some of the same issues that we had before. We have the missing people, or the people who didn't answer the question. Take those people out. We have a list here that's not sorted in a logical way. So we want to go from say from always trusted to always not trusted. Oops. Take that out again. So I'm going to Control X, Control V, always not trusted. Control X, Control V. You just want to get into a logical order. Okay, now what do we see here? Well, from the looks of it, it looks like women are slightly less trusting than men, because women are more likely to say always not trusted versus men 11. On the other hand, the differences seem to be pretty small. For example, this is almost exactly the same here. It rounds up to 11%, exactly the same. So I can copy this again for my chi-square, copy it down, and then for the chi-square, remember you need counts, not percentages. So I come back up to the pivot table, show values as no calculation. So I have my counts, and now I'm going to do a chi-square test based on those counts. Remember, the question with the chi-square test is the association between these variables, or in other words, is the gender difference we observe in how they answer the question, is this large enough that we were going to conclude that this is actually real in the population, or is it something that could just be due to chance? And I suspect we're going to get a not significant result. Let's see. And that's true. So here we find that the p-value for the chi-square is above 0.05, which means the probability that this is these differences we see here are due to chance is actually kind of high, which is not surprising. It's easy to imagine just by random chance you could get slightly less trusting female population, a slightly more trusting male population, and you don't want to then naively assume that there's some gender difference that really doesn't exist. That's what the chi-square test tells us here, is this is not statistically significant. So the difference between men and women here is not statistically significant. For this assignment, then, you're going to go and do a total of 15 of these crosstabs and get a lot of practice doing this. Once you've done a few of them, it just starts speeding up. You don't have to create things from scratch. You can copy and paste previous work into the next sheet and then just make the adjustments. Remember, it's always the variable you want to explain, which is the dependent variable, by gender, and that dependent variable by convention goes in the rows, and the independent variable, in this case gender, goes in the columns, because the idea of a crosstab is we're looking at distribution of, in this case it was attitudes about whether people can be trusted by gender, or dependent variable by independent variable. And then in the worksheet there's a link, and you can enter in your answers in that link about whether men and women are different in some way, in which way they go, or whether the difference is not significant.